You'll know by this point what factors are and how to find them. We're on the path to finding the highest common factor of some really big numbers, but before we do that, we need to understand a very particular type of number, that is the prime number. Prime numbers are special because they only have one factor pair that we can use to make them, and as a result they only have two factors. For example, to make a non-prime number like 24, we could do 1 times 24, 2 times 12, 3 times 8 or 4 times 6. There are lots of factors and lots of multiplications that will work. To make a prime number like 17, however, there's only one factor pair that will work, 1 times 17. This quality makes prime numbers so useful. Data online is protected using a particular number. Now if that particular number is made up of only two prime numbers, and these each only have two factors, it makes the numbers really hard to find, even for supercomputers, especially if the prime numbers in question are massive. And if a computer can't guess it, it keeps everything safe. The other thing you need to know about prime numbers is that they always have exactly two factors, 1 and itself. For this reason, although we would really like to say so, 1 is not a prime number. To make it, all you can do is 1 times 1, which is 1 and itself, just the one factor, not prime. So now you know what prime numbers are, how can we find them? Well, as we said, they are really difficult to find, which is part of their usefulness. The only real method was devised by ancient Greek mathematician Eratosthenes, and it's basically a mathematical sieve, where you pour a bunch of numbers in, you filter out all the ones that aren't prime, and what's left, therefore, must be prime. We're going to have a go at that kind of thing now. Either use the worksheet that's attached to this video, or draw yourself out a grid 1 to 100. Here's what we do. We know 1 is not prime. We've already said that, so we can cross it off. Next, we have 2. 2 is prime, as it only has factors of 1 and 2, 1 times 2, so we can leave it. However, we know that any other number that has a factor of 2 must not be prime, so any of the rest of the 2 times table starting with 4 can be ruled out. Cross them off. We move on to the next remaining numbers and repeat the process. Keep it if it's prime, but get rid of anything else in its times table. Keep going with your own sheets until you've got rid of everything you can. Pause the video now. Let's look at the result then. Ruling out the 3 times table, after 3 of course, which is prime, looks like this. We don't need to worry about the 4 times table, as everything in that was already ruled out by the 2 times table. We lose what's left of the 5 times table, and so on until we are left with this. And these, therefore, are our prime numbers from 1 to 100. Of course, there are infinitely more prime numbers, and you could go on forever finding them. We won't though, because what we've got here is perfectly adequate for our HCF investigations, the next step of which is to work out how to write a number as a product of prime numbers multiplied together.